Hi there. This video is looking at a number of different calculators solving a fairly sort of real-world-ish kind of GCSE maths problem. I think it's quite interesting how different calculators, like how you can do it on different calculators and what the pros and cons are of them. This is the question. Let's have a look. So a frustum is made from removing a small cone from a large cone as shown in the diagram. That gives you a really big clue as to how to solve this one. We got here a cone, big cone. You can see a smaller one on the top that looks subtracted. They have even given you the formula for the volume of a cone. The frustum is made from glass. The glass has a density of 2.5 grams per centimetre cubed. These are in centimetres. Work out the mass of the frustum. So that's where we've got to get to. Give your answer to an appropriate degree of accuracy. Yeah, so interesting problem. I always like to break these. I mean, you know, for most people who are into maths, this is going to be really easy. But let's think about what we're actually doing. First thing that I would want to do is work out the volume of the large cone. I would then want to figure out how to work out the volume of the small cone, work out the volume of the small cone, subtract them, and then multiply by the density to get the mass. So that's what I'm thinking. I think it's going to be, you know, about four-ish sort of stages. You can break it down quite easily. So I'm going to zoom out a bit and just show you. Right, so you probably know already that I like RPN. I didn't actually grow up on RPN, but since using it as an adult, I do think it is the best. The best for these kind of practical kind of problems. I'll show you why. So let's just start right at the beginning. Let's work out the volume of the big cone. We've got the formula here. So we want the radius, so we've got the diameter of the base. 12 divided by 2 is 6. R squared, so square that, let's times it by all these things, so times by pi, times it by a third. I quite like the 1 over x button. It's quite convenient as a primary key. Times it by the height, and we got the height there. One thing that's, if you're not that familiar with HP calculators and many RPM ones, is that they have this fixed display mode, which is their default. It's showing only 2 decimal points after the dot. Even if you type in an integer, it will show 0.00, which can be a bit disconcerting if you're used to how a Casio or a Sharp works. However, don't be fooled. Once you get used to it, it's actually really convenient because it tells you what the display is rounding to. It doesn't change at all the precision of what's going on underneath. It always calculates with full precision. But it's quite nice, and it doesn't sort of clutter up your display with a zillion digits that you don't need to look at. Okay, so the first thing that's awesome about RPN is that I've got a result here. I don't need to do anything with that. I can just leave that here. This calculator has got a stack level of 4, X, Y, Z, and T. Imagine them up there. You do have to kind of keep track of them. Some later RPN calculators will show you more of the stack, but that's a key bit of using one of these types of calculators. Like the stack kind of comes for free, but it's really useful. Okay, so next step is we want to work out how to work out the volume of this smaller cone, and side on this is a triangle, so we can use similar triangles, and I need to know the ratio of this triangle to this one, and I can work that out because I can work out the height here, and I can work out the height of the small one and height of the big one. I know that. So height of the small one, 15, 10 minus, got 5 here, so that's the height of the small one. Now I'm using that at the moment to work out something else, but I am going to need that height again, so I can just press enter twice, and I've pushed it up onto the stack, up to here actually. But what I'm going to do is I want to find the ratio of that to the bigger triangle, which is height of 15, divide that, 0.33, it's a third, 5/15. And then I can go on and work out the diameter of the small one. I just times that by the diameter of the big one. 4 divided by 2, that's the radius. So now we've got the radius of the small one here. Let's go through this formula again. So 2 squared pi times third times height. So the height is already here. I know it's here because I put it there. So I've got the 5 here already. I can show you it by swapping around x and y. Hit times there. And that is the volume of the smaller cone. And in y, I know I have the volume of the larger cone there. Again, I can show this to you. Swap around x and y, it's there. It's come down as we've done the calculations. So I can just subtract that. And there we've got the volume of the frustum. Times it by 2.5, and we'll get a result in grams with too many digits of precision, because that's not an appropriate degree of accuracy for this, even though I've only been using it on fix 2. But there we are. So that's RPM. Okay, so the equivalent calculator these days is probably this one, something like the fx-991CW. This is the 11C. They're broadly comparable in terms of features. The CW range has been replaced by the CW Plus range, which is definitely better, and I would not buy a CW at the moment because of other particular issues. In this case, it actually makes no difference at all. But why don't we get out the 991CW Plus? So this is actually a far more powerful calculator than the 11C in many ways. These two both, I mean, they're both the same basically when it comes to this question, but they both have something like 23 digits of precision, a very fast processor, and this one's got all sorts of extra stuff that would make it more of an advanced scientific. Anyway, it won't make any difference for this, but we'll use this one, why not? Right, so if I were working this out for the first time, I think I would just take exactly the same approach, really. Because it's algebraic, we can make use of things like fractions. Although, you know, little things like this, they do take a little bit of extra key presses, like you have to press right there to get past that. Pi r squared. So now this is something that I find a little bit frustrating about these right view style or natural display ones. So if I were to do, I need 12 divided by 2 as r. If I tried to do that as a fraction, type in 12, you can see it does this, which makes sense, you know, that's what you'll naturally think. But it does mean that you need a bracket there, and then in which case you might as well just use the divide, it doesn't really matter. Okay, let's square that. We've got square as a primary key on here. We do not have that many primary keys, so this is a luxury. Times it by 15. Gonna get a result. Yeah, that's just a setting, giving it a multiples of pi, but there we are. This is more useful to me in this situation. Okay, so that is something they fix with this calculator actually, is that this button just immediately switches it. Now then, the problem is now I've calculated the first step. The next steps I'm going to need to, I'm going to need some space basically to do the next lot of calculations. So there are different ways that you can do this. You could just press subtract now, because you know you're going to have to subtract the big cone from the small cone, but we are not anywhere near solving the small cone yet. So while you could take that approach, there's two really big downsides to it. One is you're going to have to work out all the rest of your calculations in one go. And the subtraction is actually one of the last steps. You know, it's the one just before working out the maths, so it doesn't make sense sort of logically either. And thirdly, you're not going to be able to show your working that easily, because this kind of question you need to show your working, so you don't get the intermediate values. So it makes most sense just to store this number. And the CW and CW plus series do not have a store key. They do not. So you press variable here, and then you scoot up and down. And I think this is a real, I couldn't work with this. Look, if you want to store something into Y, I believe the only way to do that is to press this button, go 1, 2, 3, 4 across. Even then, you're not done. You're going to hit OK. You're going to select store, which is at the top, and that will store it. But, you know, that's not great, I don't think. Anyway, let's store this one in A. That's the easiest place to store it. Okay, right, so the next step is we need to do this similar triangles thing. So I'm going to work out the height of the small triangle, 15 minus 10. And then I want to find out the ratio of that to the height of the full triangle. So divide that by 15. Now this is, on algebraic, this is something that I sometimes find a little bit frustrating, because on this Casio, for example, if I closed a bracket here and did divide by 15, comes up with a syntax error. And so it doesn't automatically put a bracket in on the left side. However, it does automatically put in a bracket on the right side. So you can do this, and it will just calculate it correctly. That's 15 divided by 5, yeah. So that's one thing that I do like about RPN, is that you don't need to think about what the next stage of the calculation is, you just do it. Now, okay, someone would say to me, well, then you can just chain calculations on an algebraic. You just use the answer key, yeah? So 15 minus 10, calculate that, divide it by 15. I don't mind this. You do have to be careful that you don't accidentally double hit it. And the other thing is that the answer key can be really inconsistent. I suppose if you get used to it for your calculator, then that's great. But I always feel a bit anxious. You hit twice on this and you're going to get the wrong answer. You might not realize that. Sure, that's true on an RPN, but on an RPN, usually if you hit a button twice, it's really obvious if you've done that, usually. Okay, well, anyway, we've got to a third. That's a ratio of these similar triangles. Times it by 12 to work out what the diameter of the smaller one is. Divide it by 2 to get the radius, and we're here. So we've got the radius of the smaller cone. So I'm going to square that, square the answer key again. I don't really like doing this. Times it by pi, times it by a third. Can do it like that this time. Times it by the height, which is 15 minus 10. And there we go. We got our answer for the smaller cone. So I'm going to store that into this one here. Okay, so now I need to subtract the big cone from the small cone. Now this is more direct, so you can just do Shift A minus. Now the thing is, do you remember which register it went into? You got A, B, C, D, E, F here arranged like this. But if you look at the variables, they're arranged A, B, C, D, E, F. So it's a little bit confusing. Like it's easy to, I can visualize which one I put it in because I moved to the right, but it doesn't necessarily mean that I remember that that's B. I guess it's something you'll get used to. Shift B. There we go. And there we've got our answer there of the volume, times it by 2.5. And we've got our answer to lots of with lots of digits. All right. So this is, I find this a bit clunky, really. There's a lot of storing of stuff. I did wonder, you've got a big function button here. Would that work? Could you use that to help, you know, make use of this algebraic formula? Well, you can define fx, and you could do this, but you run into problems because you can't put r squared h or a squared b into here. It's not going to work. It's not going to. It's just not going to work. It needs x. It's a function of x. So if you're going to use x, then you're going to need to work out the relationship between r and h, which I don't think anyone's going to bother in an exam. So frankly, this is sort of useless to me. I can put it like that, but this isn't, you know, this is not going to be helpful. It's of no use. I can't think of another way of doing it. Another thing you could do is you could write out the equations for all these steps and then create a big equation and work it out that way and just type it all in one go. I don't recommend that either. You're meant to show you're working. It's also just a way to get things wrong, to be honest. All right, why don't we have a look at Casio's main competition? This is the Sharp EL-W506T. This calculator, this one, I do really like it actually. I'll show you why. Let's just get into it then. Let's do the same thing. So let's do 1/3 pi. We've got pi as a primary key. It's quite convenient. R squared, so I'm going to do the same thing. 12 divided by 2 squared, and then times it by 15. And we've got a result there. So, okay, that was exactly the same as the Casio, but I've got a primary button here, store, STO. I can just store that. Let's just store that in A. Two key presses. It's amazing. All right, let's do the, let's calculate the similar triangles. So 15 minus 10. Oh, again, we run into this algebraic problem. I should have put a bracket there, but let's just try it anyway. Close bracket, divide by 15. And look at that. It will do it. And I don't think that's that ambiguous. I don't think there's nothing more dangerous about doing this than if you allow the right side to auto complete the brackets. And that's really convenient actually. So yeah, that's great. Times that by 12, divided by 2. We've got our radius, so let's work with that. Again, I'm using answer again. I don't like using answer, and there's no different for this calculator than it is for the Casio. But 2 squared times pi times 1/3. We can do it like this if we like. And times it by the height, which is 15 minus 10. Store and B. Alpha A minus alpha B. And we've got our difference, times it by 2.5, and we've got our answer there. So yeah, I think that's really good actually. Pretty direct. It also has another trick up its sleeve. You could do this. Do 1/3 pi. Let's do A for R squared, and then B. And then we've got algeb, ALGB. Hit that. Okay, so it's asking me, it's prompting me for what A is. At the moment, A is what I put in there earlier. But A here is the radius, so 12 divided by 2. And B here is the height, 15. And there we've got our answer. I can just store that. Now, this is pretty cool. I can store this into M. Let's go back up press algebraic again. So A, well, we can do what we did before, which was 15 minus 10, divide by 15, times by 12, divide by 2. I don't like the way that goes in without you seeing what you've done, to be fair. Bit of a risk there. 15 minus 10 for the height. But that is the correct result. Now, this is pretty cool. I put it into M. This has the M minus function, which was on like all scientifics up until like the 80s or something. So I can just subtract that from what was in M, second F, M minus. And then if I recall M, I've got the answer, times by 2.5. I'm going to guess I probably wouldn't commit to doing that in an exam, to be honest. It's just not direct enough, but that's quite neat. All right, so I think for a question like this, this is way better, way better. The big problem with this calculator is the register storage, to be honest. And some people are saying, oh, they quite like being able to see all the registers here. Actually, the Sharp can do that as well. The screen is nowhere near as good. I mean, the screen on this Casio is fantastic. It's a bit blocky on this, but you can see it here. Anyway, so what about some of the older Casios? Let's go back in time a bit. Let's go back to the ES Plus. Actually, this one's kind of similar to the 991EX. Yeah, let's just do it on this one. Let's run through it. Let's do, so 1/3 times pi times 12 divided by 2 squared times the height, 15. And we do have a store button here. It's under shift, but that's all right. Shift store, let's put it in A. Let's do the same thing. We know how to calculate this now, so maybe, we don't need to run through all of this. Times it by 12, divide by 2. Do the same thing, answer squared times pi times 1/3 times by the height, 15 minus 10. And let's store that in B. Alpha A minus alpha B is that, times by 2.5. See, that's actually pretty good. That is, as good as the Sharp, really. Close. It still won't do, this, which I quite like. It also has calc, which is the same as the Sharp's one. So you can do 1/3 pi a squared, oh God, what have I done? That was not right. Let's try that again. A squared b, hit calc, it's a primary key. So this is 12 divided by 2, b is the height, 15. There we go. And we can store this into, you have to store it somewhere else, not into those variable again. So store it into X. Let's go back up, run it again. This one, 15 minus 10, divided by 15, times by 12, divided by 2. B is 15 minus 10. Store that into Y. X minus y, and we have our answer. Again, fantastic. That's pretty good. All right, let's go back even further in time. 991MS. Now this screen is so clear, and this calculator just feels so direct. It's quite interesting, actually. This one feels kind of, the screen's not that great, and it feels a little bit slow, but anyway, let's try this one. So 1/3, the fractions are done on a single line, times pi, in the same place, times 12 divided by 2, squared times 15. Got that. So we're going to store that, shift store, put it in A. This has got the calc function as well. Yeah, it's got a calc function. Right, good, done that. So I know I need the brackets, so let's just do that. 15 minus 10 times by 12 divided by 2, going to give us our, oops, sorry, oh no, 15 divided by 2. I'm being silly. Divide by 15 times 12 divided by 2. There we go, we've got 2, okay. So that's our radius of the smaller cone. Square that. Again, I don't like using answer, but I don't think you have much choice really on these calculators, unless you want to store it and then use that. That's maybe a better idea actually. Times it by a third. Times it by the height, which is 15 minus 10. We've got the same answer as before. But I'm going to show you something that ruins this calculator, because when I first did this, shift store, put it into B, and now look at that. It's recalculated it. So that's quite interesting. This one did not. This one did not. Clearly Casio fixed this problem later on, but this one recalculates it with the answer, and that's why, part of the reason why I think answer is just such a dangerous thing to use. And then you're kind of stuffed here. You just have to start again, really. You kind of lost, yeah, you've lost your previous answer because that's been overwritten by this now. So yeah, that's a bit of a pain. This one does have a nice calc function, so you can use it exactly the same as the other one. Square alpha b calc, and then 12 by 2, you can put in expressions like all the other ones and it will calculate that for you. And in this case, if you store it, it shouldn't be a problem. Don't store it into A though, store it into X. Oh, you do have to watch out that you want to just do the calc on that. So 15 minus 10, 15 minus 10 divided by 15, close brackets, times it by 12, divided by 2. B is 15 minus 10, and that one you can safely store that into there. X, etc. Fine if you know that it does that with answer. But let's go even further back in time to the 992S, which behaves in exactly the same way as the 991S. And this one had the enunciator set up, so it doesn't have a, it doesn't have a single line. But yeah, this one is really good actually. So let's get stuck into it. 12 divided by 2 gives you the answer 6. That's your radius. I'm going to square it. It gives me that answer straight away. I really like that. I'm going to times it by pi, times it by a third. You see it's showing me the intermediate results as I go along. 3, I'm going to press 1 over x, which is a primary key. I do like it as a primary key. And then times it by the height, again showing an intermediate result. And there we go. Lots of digits on this one. Really nice clear display as well. So this one, I can just store this straight away into A. Right, let's just carry on. So 15 minus 10 is 5, divided by 15. There's no answer, so the answer here is the absolute value. It's just a number itself rather than a variable, which I feel much safer with, like way safer, because you know there's no risk there. 0.3. Okay, I'm going to times that by 12, divide it by 2, and we've arrived at our radius of the smaller cone. I'm going to square that, times it by pi, times it by a third, times it by the height, open brackets, 15 minus 10, close brackets, equals. Got it there. There we go. And then we can just recall A minus recall B, that times by 2.5. So I reckon this is actually the best algebraic. There's no risk of messing up with the answer function because it is just the number itself. And it shows you all the intermediate results as you're going along. So this is the best one. Obviously, I like RPN as my favourite, but I would say if you want one with a natural display, the Sharp is actually probably the best. But yeah, that's it really. Tell me what you think. Yeah, it's amazing how different all of these calculators are. So even though the Casios look very similar generation to generation, apart from the CW, they actually behave quite differently. And you know, it's not even all of them really. They're all quite different, and there's quite a lot of going back and forth on these calculators. They do different things. The CW messed up standard notation, treating it as an expression. They fixed it on the CW+. The 991ES was very short-lived because it messed up terms on it, or at least I consider it messing up terms. That could be another video sometime, but they changed it straight back again to the ES+, which was the way it had been on the MS as well. They've clearly changed the way ANS, or the answer function, works on all of these. You know, particularly ones that recalculate it. There are other Casios that do that as well. They recalculate sometimes if you show it as a fraction rather than a decimal. So you've got to watch out for that really. Yeah, but that's it really. Tell me what you think. As I said, I think I've shown why I really like RPN and why it's the most intuitive way to solve these problems. The Sharp is not bad, I do like that. Definitely the most direct of the modern ones. But actually the best algebraic was this one from the late 90s. That's it. Cheers. Bye.